Hi students, in this video we are going to discuss about factor theorem. Factor theorem. What is the statement of factor theorem? If p of x is a polynomial of degree greater than 1, if p of x is a polynomial of degree greater than 1 and a is a real number, then x minus a is a factor, let me see that, of p of x. If p of x is a polynomial of degree n greater than or equals to 1 or greater than 1, and a is any real number, and small a is any real number. So this is the condition. Now what is the first statement? So then x minus a is a factor of p of x if p of a is 0. X minus a is a factor of p of x. X minus a is a factor of p of x if p of a is equals to 0. That means if p of a is equals to 0, then x minus a is a factor of p of x. Now what is the second condition? So what is the second condition now? If x minus a is a factor of polynomial, if x minus a is a factor of polynomial, factor of p of x, then p of a is equals to 0. Then p of a is equals to 0. This is the statement of factor theorem. What is the factor theorem now? If p of x is a polynomial of degree n greater than or equals to 1 and a is any real number. So p of x polynomial is degree greater than 1 and a is any real number. First condition, x minus a is a factor of p of x if p of a equals to 0. If x minus a is a factor of p of x, then p of a equals 0. Now first we are going to condition this one, and this is a converse statement to this one. Okay, first statement is direct statement. So this is the converse of first statement. Now we have to prove both the statements. How to factor theorem prove? Now select from the remainder theorem. So what is the remainder theorem? States that we know that every polynomial of degree greater than 1, is divided by a linear polynomial x minus a, then it gives the remainder as p of a. This is the remainder theorem statement. P of x is a polynomial of degree greater than 1. X minus a is a linear polynomial. So a linear polynomial is divided. The p of x is divided by a linear polynomial. Then it gives the remainder as p of a. Now this is the quotient, and this is the remainder, and this is the divisor, and this is dividend. So now what we understand? So if p of a is equals to 0, first condition, let p of a is equals to 0, then p of x is equals to x minus a q of x plus this is 0. So whenever it is 0, it becomes p of x is equals to x minus a into q of x. That means this p of x is product of x minus a and q of x. Hence result. So x minus a is a factors. These two are called factors. Now first statement is proved. Proved. X minus a is a factor. Yes, here x minus a is a factor. When p of a is 0, yes, if you take p of a is 0 here, then it becomes automatically x minus a is a factor, because p of x is product of x minus a and q of x. So now, we are going to solve So second method also, how to prove this second method. So now, so this is also same. So from the factor theorem first, what it gives now here, if x minus a is a factor of p of x, if x minus a is a factor of p of x, now so it is also same, x minus a is a factor of p of x means, therefore let p of x is equals to, let p of x is equals to x minus a into q of x, because it is a factor, definitely it is a product of something, that means p of x will comes, so by the product of x minus a and q of x, so that is the statement why this is x minus a is factor of p of x. When x minus a is factor of p of x, we have to find p of a is 0. We have to prove this one. So we have to prove this one. Let put x is equals to a. If you substitute x is equals to a, what happens? So p of a is equals to, this is a minus a into q of a. So this a minus a means 0. 0 into q of a becomes 0. That is p of a is equals to 0. P of a is equals to 0. Now this is the second statement also verified. Second statement also verified. Then so by the conclusion here, the factor theorem is verified. Factor theorem is verified. And both statements are clear. Now, so have understood. So now we go with some example on this factor theorem. Now factorize 3x square plus 11x plus 6. So factorize 3x square plus 11x plus 6. Now, so how to find the factors of this algebraic expression or polynomial? So now you can consider first. So given 3x square plus 11x plus 6. Here only 3 terms are there. We need to split the middle term. So we need to split the middle term. Before going to splitting the middle term, so now we are in this process. Step one is, so find the product of first term and last term. That is plus 3x square into 6. So it becomes plus into plus, 3 6 are 18. This is x square. 3 6 are 18. This is x square. So now we are going to split this product into two factors. So that the sum of the factors or difference of the factors must equals to plus 11x. Like that we have to split this product. Then first we have to take the product. X square can be split as x into x. Now if you split 18, so that factors of 18, the sum of the factors or difference of the factors must be 11. So like that 18 can be written as 9 2s are 18, 9 plus 2 will becomes 11. 9 2s are 18 and 9 plus 2 becomes 11. So this is possible. Now plus can be written as plus and plus. So now we have to write this is 3x square plus 9x plus 2x plus 6. Now this middle term is splitting like this. This middle term is splitting like this. So 11x can be splitting as 9x plus 2x. Now, so from these two, we have to take the common 3x. So if you take 3x as common, so remaining will be x plus, here 3 is then x plus 3. Now you can take 2 as common, this is also x plus 3. Now x plus 3 and x plus 3, take common x plus 3 from these two terms, so it becomes 3x plus 2. Now given polynomial as factorized like this, these are the two factors. Okay, so we have to factorize like this. So now, so if you have any doubts to do the factorization, you have to please comment on this video. So I will try to rectify all your doubts. Okay, so we have to practice like this. So it is very important. You have to practice the factorization process. Thank you.